In this example, we have let z equal negative 2 plus 2i square root of 3, and w equal to negative 1 minus I. We are going to find the value of z times w, as well as z divided by w. We will represent both answers in complex polar form r times CAS of theta, and in rectangular form a plus bi. Allow me to say at the beginning of this problem that it is very possible to take z and w and multiply and divide them as they are in rectangular form. But I am going to use this example to demonstrate how we can take both z and w, convert them into complex polar form, and then demonstrate the product and quotient rule of complex polar numbers. Then we can convert back into rectangular form. In this case, in order to get to complex polar form though for both z and w, we need to find both the modulus and argument for z and w. Let's do that real fast. For z, we need to find the modulus of z, which happens to be, using the Pythagorean theorem, negative 2 squared plus 2 square root of 3 squared, all under a square root. Well, for this one, the square root of, or negative 2 squared is 4. 2 square root of 3 taken to the second power, that's 4 times 3, or 12. Which means that we have square root of 16, which is just 4. We also need the argument of z. If I use arctangent for that purpose of the imaginary component over the real, that'd be 2 square root of 3 over negative 2. Well, this would be arctangent of negative square root of 3 over 1 if I simplify that. But I also do need to keep in mind that the original complex number, negative 2 plus 2i root 3, negative 2 plus 2i root 3 would have a negative real and a positive imaginary. So that would be an angle measure in quadrant 2. And this ratio of square root of 3 over 1 we do recognize. This would be in quadrant 2, this would be at 2 pi over 3. So I have my representation for z, now in complex polar form, is 4 CIS of 2 pi over 3. I also need to be able to expand w using the same process. The modulus of w here is going to be, again, using the Pythagorean theorem of negative 1 squared plus negative 1 squared under a square root. That is simply going to simplify to just the square root of 2. The argument for w, using arctan of the imaginary over the real, this would give me an angle measure in quadrant 1 if I were to use a calculator to try to evaluate that. But for negative 1 comma negative 1, that means that I have a negative real and a negative imaginary. So w should be down here in quadrant 3. And if I were to evaluate arctangent of 1, this is a ratio I should know. Arctangent of 1 would give me pi over 4. But the version in quadrant 3 that I would want instead would be 5 pi over 4. So we have both our modulus and argument for w. So w, therefore, is the square root of 2 times CIS of 5 pi over 4. With that information, we now can do the multiplication and division using the complex polar product and quotient rule. For ZW, by the product rule, what we're going to do is multiply the moduluses. So we're going to take 4 times the square root of 2. And then with the angle measures, the arguments, we are going to add them. So that'll be 2 pi over 3 plus 5 pi over 4. This would be, if I simplify, 4 square root of 2 is as simple as that can get. And then 2 pi over 3 plus 5 pi over 4, those would have a common denominator of 12. So that'd be 8 pi over 12 plus 15 pi over 12. So that'd be 23 pi over 12. We can approximate that using a calculator. If I were to expand this, this would be 4 square root of 2 times cosine of 23 pi over 12 plus I times sine of 23 pi over 12. And again, I can use a calculator to approximate that by distributing the 4 square root of 2 accordingly. So here, we will take the 4 times square root of 2 times cosine of our angle measure 23 pi over 12. Since we're working with a radian measure, do make sure that we are in radian mode. That gives us approximately 5.464 to 3 decimal places. And we can also do the same thing with the value for sine. So 4 times the square root of 2, if I distribute that to the second term, times sine of 23 pi over 12. For that, I do expect a negative value here because that would be in quadrant 4. Get negative 1.464. That would be my answer. Z divided by W is going to work in the same way. However, instead of multiplying the moduluses, we're going to divide them. So it'll be 4 divided by the square root of 2. And instead of adding the angle measures, we're going to subtract them in that order. We're going to take the first angle measure, 2 pi over 3, and we're going to subtract the second angle measure of 5 pi over 4. You can simplify 4 divided by the square root of 2. That will come out as 2 square root of 2 times CIS of 2 pi over 3 minus 5 pi over 4. That again would be 8 pi over 12 minus 15 pi over 12. That's negative 7 pi over 12. And if I use the exact same process to expand CIS to cosine of this and sine of this, we can find this in rectangular form. So this would be 2 square root of 2 times cosine of negative 7 pi over 12. That would be an angle measure in quadrant 3, so I expect a negative value from this. Negative 0.732. And I would also expect a negative value from working with sine of this angle measure as well. So negative 7 pi over 12 gives me negative 2.732 times I. So that would be my second solution in rectangular form. Again, we could have done that by calculating and multiplying, dividing in rectangular form first, and then convert into complex polar form. But I wanted to use this case to demonstrate how to work with both the product and quotient rules.